I'm Caius Van Hout,
I'm Liam Sweeney.
I'm John Hughes.
and this is Trophic
Cascades
Cascades
and
and Food
Food
Webs.
Webs.
Enjoy.
Trophic levels are organized hierarchical stages of an ecosystem that organize organisms based on the way they obtain their energy as well as their position on the food chain. The sun serves as the ultimate source of energy but is not considered when studying trophic levels. The first trophic level is the primary consumer, which forms the base. The primary consumer does not consume other organisms. Instead, they convert inorganic materials such as hydrogen and oxygen to create organic compounds through photosynthesis. There are many kinds of primary producers, ranging from land plants to phytoplankton to algae. Above primary producers on the trophic scale are primary consumers. Primary consumers are organisms which eat the primary producers and are the first ones to consume organic matter. Herbivores serve as strict primary consumers, such as rabbits, giraffes, and zebras. Omnivores also act as primary consumers, such as bears, raccoons, and pigs. However, they can also eat non-plants, making them secondary or above consumers as well. Secondary consumers eat the primary consumers, introducing predation into the trophic levels. Carnivores such as lions and tigers act as secondary consumers as well as many other omnivores. Above the secondary consumer are tertiary and quaternary consumers. As you move up the trophic levels, the organisms on top will continue to eat the organisms below it, while also falling into many trophic levels. Finally, alone at the top will be the apex predator. Certain animals that have no predators trying to consume it, such as whales, will be at the top of the food chain. Trophic levels are generally limited to 5 to 7 consumers in a functional ecosystem. This is due to the transfer of energy following the 10% rule. The 10% rule states that every time you transfer energy among a trophic level, only 10% of it is actually passed to the next. Because of this, 90% of energy is lost at each step, starkly decreasing at each level.
Let's crack the walnut that is trophic levels. Anyone can predict the changes that'll happen in a community of organisms based on what trophic level in particular is affected. Take, for example, the top-down cascade, which is when we see how the secondary consumer affects the rest of the web. So if we are given the standard trophic cascade of primary producer, consumed by primary consumer, consumed by secondary consumer, then we can concur how the food web will be affected if we increase the secondary consumer. If we were to increase the secondary consumer, then we can assume that the primary consumer will become more rare because their population is being eaten. With more primary consumers gone, then the primary producer populations will increase because they are not being consumed. However, if you instead decrease the secondary consumer population, then the primary consumers are going to be able to have a lot more babies because they are not being consumed. But if there's more primary consumers, then the primary producer is eaten. This is the top-down cascade. But however, we're going to take a look at the bottom-up cascade, which is when the primary producers affect the rest of the web. So if you were to decrease the primary producer, then at first both consumer levels would grow because there's enough food to grow around, so they'd grow and grow. But that won't last because eventually food will run out and all the trophic levels will decrease and become scarce.
Think of top-down trophic levels and how that affects certain ecosystems. Picture a simple food chain of sea otters, sea urchins, and kelp forests. Sea otters prey on sea urchins, while urchins prey on kelp in specific kelp forests. If the sea otters decline from the food chain completely, then the sea urchin population would skyrocket and the kelp will be eaten until there is none left. When you introduce sea otters back into the community, kelp production will increase while urchin populations plummet from sea otters. Compared to top-down, there are bottom-up trophic levels as well. Here you are looking to see how the primary producer will alter the food chain in specific trophic levels. For example, in grasslands, the amount of sunlight, water, and soil determine the growth rate of grass. If less rainfall were to happen, then this would cause grassland production to decline, which provide less resources to herbivores such as deer, which can also limit the production of predators like wolves. This is due because, well, they're predators and they don't want to have a lot of prey because deer aren't getting the nutrients they need from primary producers. And apart from that, one hidden player in the food web is the detrivore. When an organism dies in the food web, the nutrients need to be returned back to the ecosystem if the whole body is consumed by another consumer. The same can be said about feces. Animal droppings must return the nutrients to the ecosystem in some way in order to provide a stable community of organisms. Enter the detrivore. Detrivores are organisms that break down dead organisms and feces, recycling nutrients back to the soil so plants and other producers can grow from them. Think of organisms like earthworms, fungi, and dung beetles. The detrivore therefore connects all trophic levels, as will eventually consume a part of them once they are dead, as to return nutrients back to the ground. Because of this, the trophic level of detrivores is a primary producer, and every level of consumers as there is nothing it won't eat. Because of this, it is sometimes kept separate from the producer-consumer web, and its level is said to be its own thing, which is the detrivore level.
Thank you for watching.